Yeah, I think we started with the recording now, so I will start with introducing our today's speaker. It's a pleasure to introduce Lea von der Heide. She is a PhD student, somehow being at the University of Munich, but also kind of being at the University of Mannheim. Yeah, she's getting close to getting her PhD sometime soon, so she's at the very end. So fingers crossed for Lea. Today, Lea is talking about biases in LLM-based predictions of voting behavior in the European elections. It's a huge pleasure to get her or to have her today presenting on that topic, which is also related to her PhD. The talk will be somewhere between 45 and 60 minutes. And afterwards, we still have some time for a Q&A. So if you have questions, keep them in mind, write them down. So there will be time to address these questions after Lea's talk. And now I will just hand over to Lea. And again, many thanks for having you today.
Thank you so much, Jan. I'm really, really happy to be here. So thank you for inviting me. Yeah, before we dive in, I just wanted to give you a quick, overview or walkthrough of what we're going to cover today. So I'm going to start with a really basic, quick theory intro of how LLMs even work. And then also the idea behind LLM-generated synthetic samples that, we've had a lot of talk about and that this research is also based on. And then the reasons for why that actually might not be such a good idea to use them. And then we'll also look into the practice. So how does one actually go about creating such a sample? How did we do it for our research that we did? And then I'll also, of course, show you that test case, which is predicting the European election voting behavior. And then, of course, we'll look at the results of that study and the implications. And yeah, like Jan said, we'll have plenty of time for Q&A, I hope. And yeah, also a quick starter. I tend to talk really fast. So if there's ever something that, I went over too quickly and you would like me to reiterate because you didn't quite catch it, please feel free to drop a message in the chat or, ask whether I could repeat it. I'll also try and, take little breaks between the sections so that we all have a chance to digest a bit or ask little questions about the part that we just went through so that it's not 50 minutes of just me droning on like a professor. That's not what we're here for. Okay. Then I'll just try and share the correct screen. I hope this works for everyone. All right. So yeah, like I said, of course, we're here today to learn about biases in LLM-based predictions of the European Parliament elections. Wanted to quickly mention that the study I'll be presenting today is joint work with Caro Hensch, Alex Wentz, and Bolema. So I'm really thankful to them for their collaboration on this project. But before, we look into that, how did we even get to this point that we're trying to make predictions based on LLM-based samples? Well, that's because, as we're probably all aware, survey research has been facing some pretty big challenges in the past years. It takes a lot of time, takes a lot of money, and a lot of effort to design a high-quality survey. And in particular, these are issues considering coverage, sampling, non-response. This includes reaching hard-to-survey populations, unit, item non-response, sensitive topics that participants may be reluctant to respond to. But of course, we're in the age of AI, and AI is being hailed by some as being the cure for everything. So the question really is, how could LLMs help us with these challenges in survey and public opinion research? And the answer there is basically based on two characteristics of LLMs. And the first one is that LLMs are trained on human-generated text data. So that means that that data, and therefore maybe the LLM output, could reflect attitudes and behaviors that are prevalent in the population, reflecting that back. And the second idea is that LLM output actually represents a conditional probability based on what it learned from this training data and based on what is contained in the prompt, which is the input that we give to an LLM. So for example, if the prompt was "I voted for," then the LLM learned that the likelihood of that sentence to be completed with the words Harris or Trump would probably be larger than the probability of that sentence to be completed with the word banana. And if we change this context by changing the prompt input, then the underlying conditional probability distribution changes, and consequently the output changes. So if we change our input to "I am a Republican, I voted for," then the underlying distribution would shift so that it's now more likely for this sentence to be completed by Trump than by Harris. But both of those are still more likely than the completion to be banana. And if we, take this idea further and we make this context that we give even more specific, then we could condition an LLM to give an input or to give an output from a very specific person's perspective. That's the basic idea. And so ultimately, if we scale this up and didn't just do this for one person, but for, several thousands of people, then we could create entire synthetic samples with LLMs simply by anonymously feeding them relevant individual level sociodemographic and attitudinal information. And then we could prompt the LLM to respond to survey questions from that person's perspective. So just over 2.5 years ago, with the public release of ChatGPT, which, is one of the most popular large language models out there, or basically a chat application of one of those most popular ones, there were first scientific studies that suggested that this was actually a promising, approach that had a lot of potential. So the one paper that went really viral was the one by Lisa Argyle and her colleagues in political analysis. But then there were also a few other papers that tried similar approaches, all based on kind of synthetic samples. And as a result of that, and of course, the overall AI hype that we had, there is an increasing number of enterprises that also offer survey and market research solutions that are based on LLM synthetic samples. So this is just, a quick search of the internet that you see here. There's quite some companies doing that now, startups mostly. And one of those examples would be that AI startups have actually tried and failed to predict election outcomes using synthetic samples. So maybe this actually isn't such a good idea after all. There's, some studies that say, yes, this works, but then there's also some evidence that it doesn't. And there have been a number of studies published since then that are challenging these initial results. And particularly, they found biases in such LLM synthetic samples regarding certain population subgroups, but also regarding different populations as a whole overall. There we go. So it's possible that these biases that those studies have identified against non-weird or marginalized groups, because that's what they were, are actually due to the unrepresentative training data. Because in that data that LLMs are trained on, the US and English-speaking contexts are probably dominant, and that's for a bunch of reasons that we're going to walk through now. So one such factor is language, because more than 50% of content on the internet, which, is what LLMs are trained on, is estimated to be English. So the amount of available native language training data for LLMs is considerably smaller for any language or for any country whose native language isn't English. So for example, 5% of internet content is estimated to be German, and about 0.5% of internet content is estimated to be Swedish. And then another factor is that the relationship between the societal and political structure of a country and public opinion differs between countries, and that may not be sufficiently covered in LLM training data. So, for example, if we're thinking of, the comparison to the US again, political attitudes are, of course, really different in a two-party system like the US, where you have really aligned attitudes along the ideological camps, red and blue, black and white, whatever you want to call it. Whereas in multi-party systems, that's much more complex. You have many more dimensions of alignment or realignment. but a lot of internet content actually lacks this nuance. And then finally, it's likely that there's coverage bias, which is caused by the digital divide, because there may be differences between the target population that we're trying to learn about, whether that's, the US population or the German population or any of those subgroups, and the people who contributed to or are featured in the texts that are actually the base of LLM training data. Because first of all, who has access to the internet, and then from that, subset, who contributes to the internet varies across countries. And that behavior actually could correlate with public opinion. So for example, it's known that people with stronger or extremer convictions tend to be more outspoken in online discussions. So those online discussions will reflect maybe more extreme or more convicted viewpoints. And what we also know is that the training data for LLMs isn't actually, first of all, it's not the entire internet, but then also it is not a random sample of internet text. It's a really large corpus, but it's not very diverse. We don't know this for all of the models out there, but for example, for an older version of GPT, for GPT-3, we do know. And there we know that it relies on very few sources. And they generally tend to be authored by rather homogeneous communities. So for example, it relies on Wikipedia data, but only on the English Wikipedia. And that Wikipedia data is authored by majority of authors that are males that are sitting in the US, because those people apparently write a majority of Wikipedia articles. So of course, that could also be reflected in the information and the data and what the LLM actually learns. So all in all, this means that the knowledge sources of LLMs are really concentrated on the English-speaking and US context, which, and this has actually been shown in general, reflects in LLM outputs. And these biases then, of course, can challenge the validity if we think about LLM-based samples that we just talked about. And that risks reinforcing existing biases, not just that we have in social science research, but also beyond. If we use that data for policymaking, then it will bias policymaking and ultimately society. So really, we need to test the application of such samples in different contexts that go beyond, just the US. And this is where my first checking is, first of all, for me to take a little, water break, but also to check if you have any questions so far, whether I talked too fast or whether there was some, understanding issue in terms of substance. So if you have a question, just, raise your hand or maybe write it in the chat or something. A raised hand. I'm trying to do this. Oh yeah, there we go. Okay, great. Thank you. That's so great. Thanks for the feedback. Perfect. Then we'll just continue. And again, if any questions pop up, just feel free to, drop them in the chat. So what is actually missing in what we know so far? There are, in fact, some studies on attitudinal biases in LLMs, but they have typically employed country-level prompting only. So that means, how would a person from Spain answer this question? And they haven't really used these individual-level personas that we talked about earlier. So of course, if we only ask this very generic question, how would a person from Spain respond to this question? That, of course, will only give very generic output and doesn't really test LLM's capabilities for producing estimates based on really nuanced individual level information, which might, of course, if we have this nuance on the individual level, result in better aggregate results, because that's made up of that. On the other hand, we do have research with LLM synthetic samples based on such individual level characteristics, but that has mostly been focused on the US. But even there, it's identified some biases. So nobody has actually tested whether cross-national differences depend on the language or the content of the prompt. If we're already thinking about, training language and data, nobody's actually really tested that. And then another thing is that, of course, the added value of synthetic samples would actually lie in an ability to predict something that we don't know about, right? That's something that hasn't happened yet, an unobserved outcome. So a future attitude or future behavior, such as, and this is getting us closer to where we want to end up today, future voting behavior, which would actually be helpful because then we could know whether high quality survey data that we already have can be recycled beyond its initial context of data collection, but also we would then know how much past information from surveys would we actually need to be able to use it for future, predictions. But most existing studies have really been focusing on predicting the past. So, trying to predict or trying to see whether LLMs could mirror voting behavior as we have it reported from like past elections, for example, that we already know about. So we have something to compare it to. But, that's not really informative because we already have that data about the elections. So what we really wanted to do with this project is filling in these gaps and seeing whether LLMs can predict aggregate results of future elections that haven't happened yet, how that performance differs across countries, but also across languages, how the performance differs depending on the information we provided related to what I just mentioned. And then, of course, also whether the same goes for every LLM or whether there's differences between the LLMs there. And as a test case for answering these questions, and of course you knew about this already from the title of this talk, is that we tested how well LLMs would perform when we were asking them to predict Europeans' voting behavior in 2024, and whether we could detect any systematic biases in performance there. So why vote choice and why the 2024 European elections? Well, first of all, voting behavior is a real-world example. It's an important yet challenging prediction task in public opinion research. And because of this relevance of elections and because of the predictive challenges, there's likely a lot of online data about it, right? Both academic, but also non-academic, which actually makes it a really easy, low-hanging fruit for LLMs to predict. It's something that there's a lot of, talk about online, so probably also featured in the training data. But at the same time, voting behavior depends a lot on the national context, which is exactly, what could be biased, what we talked about in terms of training data, and thereby the performance. So if we're testing voting behavior, we're, testing this argument that we just made earlier about biases in the training data and how that balances out with a popular topic versus the individual context. Now, in the European elections, which take place every 5 years, citizens across all 27 European Union member states elect representatives from their countries and their national parties to the European Parliament, where they organize themselves in transnational factions. So this is actually a great opportunity for us for testing LLM predictions in diverse linguistic, social, political, and digital contexts, because we have 27 countries. And on top of that, since these elections take place in countries simultaneously, we even have a common temporal reference point. So if we're thinking about, training data cutoffs and just the state of the world at the point of an election, we have the same state of the world. They're all, voting in the same situation. And the fact that their elections are still for the same electoral body also really helps us with comparison, right? And then when we started this project, the 2024 European elections were actually just around the corner. So we were actually able to perform a real prediction as opposed to doing this, predicting the past, which a lot of the past research already did. So this was really an ideal case for answering all of these questions that we asked. Now, if we're thinking back to the research questions and the different dimensions that we wanted to test, we wanted to examine biases across countries, across languages, across, depending on the information provided, and several different LLMs just for validity. So accordingly, we have 4 experimental conditions here that we vary. So in the country dimension, we have the 27 EU countries, which we can differentiate by region and by language family. And conveniently, we also have survey data that covers all of those 27 member states. For the prompt content, we once test how performance works when we only give demographic variables. And then once we add attitudinal information about the respondents from the survey. Regarding the prompt language, we use English for all 27 countries. And then additionally, we test the respective native language in a few selected countries just for, scope reasons. So we selected Germany, France, Poland, Sweden, and Slovakia, which are countries that are representing different regions within Europe, but also different language families. They have different population sizes and, different language sizes more generally globally, as in, how many people speak that language globally. And of course, political positions within Europe, like, Euroscepticism, but also political power. And then we have Ireland as a baseline because Ireland has English as a native language. So that's a good point of comparison. And then finally, on the LLM level, we compare 3 models. So we compare GPT-4 Turbo, Llama 3.1, and a version of Mistral, which were at the time we did this. So think back, May, June 2024, the most capable models of their family at the time, both in terms of multilingual performance, but also in terms of solving complex tasks without fabricating too much. And by now we're at, GPT-4o, GPT-5. So, things are moving fast, but this is what was the best that was available less than a year ago. So GPT, just to give you a bit of background, as you probably know, is owned by the company OpenAI, which is one of the most powerful and popular LLMs out there. But it's also proprietary, which means we don't know and we can't change its secret sauce, really. It costs money to use it, and it's a bit questionable in terms of privacy because, we're just basically giving data to a third party, and also reproducibility is a bit shaky because they might just change their models at any time and not tell us, or, even if they tell us, we can't really control it. In contrast to that, we have Llama, which is owned by Meta, still a private company, but it's still open source. And we have Mistral, which is built by a European company. They're both open source, which means we have a little more insight into how they were built. Not perfect, but a little bit more. And we can access the models free of charge and locally, provided we have enough computing power, which is an advantage, of course, in terms of cost, because we don't have to pay to use them, except for the computing power that we hopefully have somewhere. Privacy-wise, it's better because we have the models locally. We're not sending data to any third-party company. And reproducibility, because once we have the model locally, then, it can't be changed. We have it downloaded locally. So they can change the online version, but not the version that we have. But these models might not perform as well as some of the industry leaders. There's always drawbacks, right? But that's exactly why we want to compare them, to kind of see where the trade-offs lie. So let's look at how we did this in practice. So first, we actually had to create the personas, so the little profiles based on a survey sample. And for that, we used the most recently available Eurobarometer data, which was from a year before the 2024 elections, which is, of course, due to data archiving, right? That always takes a while. But also, this serves a really good test case for whether we can actually use this older survey data to make predictions. The Eurobarometer, just for those of you who don't know, it is a really high-quality survey. It's based on a stratified probability sample. Data is collected in face-to-face interviews. Residents of EU member states that are at least 15 years or over and are EU citizens. So that serves as a really good baseline sample here for us. Of course, we only filtered out voting eligible participants, so depending on voting age and citizenship, meaning we had about 1,000 personas per country. And then for the demographic variables, we included age, gender, education, occupation, class, and urbanity. And then for attitudinal information, we included political interest, ideological left-right self-placement, their attitude towards EU integration, and whether they trusted the EU. And if we had any missing variables, any missing values on any of those variables, then we used multiple imputations so that we really had a full profile for every person in that survey. Just to give you a bit of a glimpse into how this looks like in practice, we have, the Eurobarometer data set at the top with the variables already coded as, strings, so like text data, so that we can put them into the profile. And then we insert that into a text template for every survey respondent, once with the full version, once only the demographics. And then for the 5 countries that I mentioned, we also did this in a respective native language. So we have all of this text also in German and Swedish and Slovakian and Polish and French. And then that way we ended up with, several string variables in the data set containing this entire persona text with different amounts of information and in different languages, with which we could then automate the task and just parse all of these little profiles. So that's what you have at the bottom here. And then this is actually like one of those persona profiles, just an example of the English version here. And you have the variable parts in bold, and then the attitudinal information underlined just for, illustrative purposes here, of course, not in the actual text. And so as you can see here, actually, what we did is beyond the demographic and attitudinal information, we gave the LLM some more information. So about the parties that were competing in the respondent's country, because these are different from country to country, even though they then organize in international factions. We explicitly mentioned parties that are currently represented in the EU Parliament, as well as every party that was polling above the electoral threshold at the time. And then anything below, we just said was like several smaller parties. Why did we do this? Because the LLMs can't know this. Their training data cutoff was December 2023, which was before, parties decided to compete in the elections. And back then, they couldn't access the internet, the LLMs that is. So they had no way of knowing what parties were competing, and we're not expecting them to make predictions based on, parties that have newly formed or that don't no longer exist. Well, of course, that's going to be wrong. So we wanted to level the playing field there a bit. But nevertheless, to really make sure it's a prediction, we collected the data before the elections actually took place. And at this point, you might wonder why we didn't customize these prompts further and included variables that are like, more country specific in terms of vote choice. So maybe, climate change was important for people in Germany, or migration was important for people in Italy when it came to, casting their vote. Because of course, in not doing that, we probably limit some of the predictive accuracy. But we actually had 2 reasons for not doing that. One was that our premise is that researchers have limited information due to limited availability of, recent survey data or detailed survey data, like choose one, basically. And we were interested, like I said before, whether LLMs can be useful based on like the very basic data that most surveys provide anyways. And then the other reason was that we wanted to ensure comparability. So we were wondering, given the same amount of information across populations, do LLMs perform better at predicting some people's voting behavior than others? Because, if so, then that would be problematic, probably. That would be unfair. And then we also, as you can see here, instructed the LLMs to keep their answers short, both so that we could save on, money, because the cost is determined by how long the prompt is and how long the output is, but also that it would be easier to extract the party names from the response so that we don't have to, look for it in a really long answer. And then we also added a sentence for making a prediction as good as possible, because we know from previous work that LLM guardrails sometimes prevent the models from giving political opinions or making recommendations, and they sometimes respond that they cannot give an answer based on only this information. So we try to circumvent that a bit by really just saying, make your best guess. And then, like I mentioned, we did this a week before the European elections, where we prompted the large language models with these personas. And since we have a bit of time for this today, I want to give you a little insight into how this or other type of kind of mass requests you might want to use in your research can be done. So the most basic option would be to go to, for example, chatgpt.com and paste in all the personas individually, which you would probably have to do in a new chat for every persona, so that, questions you asked later aren't influenced by the previous information and output. If we're thinking of traditional response bias and panel conditioning, who knows how the LLM would be influenced by that? We wouldn't want that. So that would be an extra step. And then considering that in our case, we had close to 60,000 prompts because we had 26,000 people with 2 prompt versions plus the 10,000 native language versions. That would probably take quite some time to do manually, and then you'd still have to export the response back to some data set too. So, obviously we don't want that. So we didn't just, paste that in the chat interface. We automated this. Luckily, there are already R packages out there. For example, there's one called RGPT, which you can access the OpenAI API with. So you can access the LLM online, loop through all of your rows of data with one command, and specify all the parameters just in that. What parameters? Quick excursion on that. The ones that we specified or modified were the temperature and the maximum number of tokens. Temperature, plainly put, is the degree of randomness of the LLM output, because remember that the output is based on an individual probability distribution conditioned by the preceding words. And then from that probability distribution, one word is drawn that, the sentence should be completed with. And you do that for every word. And a temperature of 0 would imply that the LLM always returns the most likely response according to that probability distribution. A temperature of 1 or above would mean that the distribution would, or like that the LLM would sample from that distribution at random. And so we set the temperature to 0.9, so quite high, quite random, you could say, because we know that human voting behavior is deterministic. So, humans don't always vote for the most likely option. So we wanted to allow the LLM some leeway and also not always pick the single most likely option. And the other thing we modified was the maximum number of tokens. So tokens are really subdivisions of words, or more precisely, common sequences of characters occurring in natural language, which is what LLMs learn to predict. And based on what we know about what one token corresponds to, which is roughly 4 characters in English, or like one English word is 3/4 of a token, we limited the output the LLM was allowed to give us back to 40 tokens, which allows for a complete sentence in all of the languages we investigated. Really, all we wanted was just, did you vote yes or no, and what party did you vote for? So you could either, answer no, or I don't know, Front National, or whatever other party there was in the country in question. But we also wanted to give the LLM a chance, like if it really needed to output a sentence, it can output an entire sentence. What's important to know there is that that doesn't necessarily mean the LLM will adjust its response length to that limit. It just might just be that if it creates a longer response, it will be cut off after 40 tokens. But that is something we have to work with as a compromise between like efficiency and cost. The one other thing that we did is setting a seed, which is similar to setting a seed in any kind of other sampling operation that you do in R or another programming language. So that way we try to ensure reproducibility by sampling the same response if we ran this again. Unfortunately, with proprietary models like GPT, it's not always guaranteed that this actually does what it is supposed to do, but it's our best shot that we have at reproducibility. So we tried. And then we actually, so I just showed you the code for this package, RGPT. We actually access GPT via a service called Microsoft Azure, which is a cloud service that hosts copies of GPT models. Luckily, our lab has this subscription. And basically, so we used like Microsoft Azure's computing power instead of OpenAI's. And we did that because Azure hosts the LLMs on servers in Europe. So we can be sure that the survey data we actually send to the LLM that we use as input is covered by European data privacy laws, because that's another question you want to ask yourself, right? Like, I mean, you collected survey data, but those people didn't really necessarily consent to having that be shared with a third party, with an LLM that might use it for further training. So we really wanted to make sure that that's, covered by those standards. And then for the open source models, the approach was still a bit different because we can download those models locally, like I said. And again, thankfully, at the Munich Center for Machine Learning, where I'm a fellow, we also have access to some pretty powerful computers, which considerably speed things up, because loading an entire large language model on my little laptop that I'm like presenting from today would probably fry it. So really thankful I had access to those supercomputers. And for that to work, you actually need some Python packages and access LLMs via a platform called Hugging Face, if you don't know that, which hosts a bunch of AI models, and then you can load them onto your local, computing infrastructure and run the requests and store the output there. But all of that could be done within a day per LLM. So, really, really fast compared to when you did this on like a smaller scale computing source. So that's a bit on how to implement this, actually. I hope we're all good so far. If there's any questions about this, practical implementation that you didn't get, feel free to ask it now. Okay. When designing the LLM prompt, were you considering how the prompt length would impact the output, and what other factors were you considering, and how did you balance them? So I'm guessing you're thinking about kind of like memory and how it would, like how the LLM would forget. We didn't explicitly test that, but we did run some, of course, before feeding all several tens of thousands of requests, we did some tests with a smaller set to see whether this generally works. And it seemed like, it wasn't forgetting, but of course we can't at this stage know what information it considered particularly important from the prompt. We did a previous study where we actually looked at this in more detail, like what factors in the prompt were more important to, to make the predictions. But we didn't do an explicit test of, context windows. What we did do is that we, ran new requests. So we refreshed the memory for every little persona that we had, so that the overall context was just always the length of the prompt. So that should also ideally limit it. I can definitely show the prompt slide again. There you go. We didn't run any regressions in this particular project. We did a previous project based on just German survey data, and where we didn't do, a prediction, but kind of like predicting the past, where we compared regressions based on survey data with that of LLM data. And we found there that actually there were quite some differences in the predictions, as in, what factors were influential for predicting vote choice between the LLM and the survey data. So from that point of view, we know that LLMs, consider factors differently, or, maybe over rely on certain parts of the prompt than others. I hope that's what you mean. Yes. How do you feed that data, and how do you use it? How do you tell it to use that information? I can reiterate that. So basically, this is the information that we use, and this is what we give to the LLM, right? Like, of course, we can't ensure that it doesn't draw on whatever other knowledge it has from the training data beyond this information, but that's actually the entire premise, right? We're telling the LLM, pretend that you're this person, and based on this information and whatever other information, whatever other things you have learned from your training about people like this person with these, this university background, or this working status, this, place of living, this gender, what would that person vote for? So LLMs are just really made to follow the instructions that we give it in the prompt. How well they do so is the question, really. And yeah. What does the ESS have to do with it? So we use the Eurobarometer, and basically we just use that to build these little profiles, right? So we took the Eurobarometer data, that's where we got the information about the people, and then based on that information, we did a little profile that looks like this for every person in the survey. And that's what we gave to the LLM to, you know, ask it how that person would vote. And Amir wanted to see the one before that, this one. Okay. Great. You're welcome, Claire. And then I think there's a question in the Q&A part. What would you recommend as a computing power of your local machine to run the llama model locally? I will have to get back to you on that because I don't remember the exact, you know, the exact, how do you even call that? Well, capacities, I guess, that the server that I hosted it on had, but I will get back to you about that. I can check. It wasn't crazy much. I wasn't trying to block too much CPU from, you know, all the other researchers. But definitely, you know, more than my laptop, less than, I don't know, a space supercomputer. Yes. Okay. Thanks for all your questions so far. So now that I showed you how to do this, what did we actually do with the data we collected? So after we collected this data just before the European elections, we compared the responses once the elections were over to the aggregate election results per country. Because, you know, once the elections were over, we had that. And to do this, we extracted the vote choice from the responses the LLM gave us, and then we weighted those predictions according to the survey weights that we had in the Eurobarometer data, because that comes with weights to, you know, make the sample even better and more representative. And then we compared the differences in turnout between the prediction the LLMs gave us and the actual election per country. And then among those who voted, we also compared the difference in vote shares. And then we looked at several dimensions that were in line with, you know, the arguments I presented earlier. So whether there were differences by region, by language family, by prompt language, and by the information contained in the prompt. Now, finally, for some results, the big question was, can LLMs predict the aggregate results of the 2024 European elections? And the answer I would give is no. They vastly overestimated turnout, and in reality, there was much higher variation in turnout between countries. So, you know, actual turnout you see here on the left, the median was about 50%, but there was a lot of variation, like somewhere was some country with like over 75% turnout, and then some with really low turnout. Whereas the predicted turnout, you know, was basically at an average of 83. And there was a lot lower variation. So first prediction of voting behavior, just turnout, was just really off. Then when we look at party vote shares, the LLMs also performed poorly on all three of the indicators or metrics that we had there, which was predicting the winning party, the party's ranks, and the actual vote share. So at the really most basic level, for less than half of the countries, the LLMs correctly predicted the most popular party, less than half. And then when we were ordering the parties by popularity per country, so again, not even asking about exact vote shares, just, you know, popularity, rank order, they only got 8% of those correct on average per country. And if we're thinking about that, there's roundabout a maximum of 10 viable parties competing per country. Like there's a lot of small parties, but the really viable ones usually aren't more than 10. That means they only got the rank of one of those parties correct per country on average. But for most countries, the median was actually 0. And then if we look at the predicted party vote shares, the average difference per country between predicted and actual vote shares was between 7 and 15 percentage points, the average. So this is actually more than some parties' vote shares was to begin with. And if we're thinking about, you know, how much a few percentage points of vote share make a difference in an election, this is actually a lot if there was a 7 to 15 percentage point average difference. Yeah, so much for that. And there was actually quite a bit of variance in these divergences, both within and across countries. So in particular, we found larger divergences between predicted and actual vote shares for parties that do not belong to the Green or left parliamentary group. So here you have the parties broken down by country, which is a bit hard to see, but believe me, it's the case. So this actually includes both the centrist groups that house the formerly big People's Party, so the Conservative People's Parties and the Social Democratic parties. So that means that either the LLMs were really overly confident in popularity of parties that belong to the Green and left groups, or they were better informed about the voters of these Green and left parties, which means they were better able to predict who will vote for them. And either of those two options would constitute a bias. So either way you see it, that's a bit problematic. We also found that the predictions of turnout, which are blue here, were better for countries that actually had higher turnout, which, the actual turnout is yellow here. And this is, of course, because, as we've seen earlier, the LLMs tended to just blindly predict a high turnout regardless of the country in question. And what was interesting is that the LLMs didn't even account for compulsory voting, which is, the case in 4 countries, and which is information that should be included in the training data. Like that is something LLMs should know if you ask them. No, because, they don't really have knowledge, but they should be trained on this. But as you can see from the black lines here, the biases lie in a different dimension. So we have 2 countries with 2 compulsory voting and very, low differences between predicted and actual turnout, and then 2 countries with very high differences between predicted and actual turnout despite the compulsory voting. And the dimension there is where these differences lie are actually, as we expected, region and language. So here you can see the differences in turnout and vote shares broken down by European regions on the left and language families on the right. And I colored Western Europe or Romance languages in orange, Northern Europe or Germanic languages in yellow, Southern Europe or Baltic languages in medium blue, and Eastern European or Slavic languages in dark blue. And then we have Uralic languages in pale blue. And of course, regions and languages aren't perfectly mapping onto one another. And that's why we did this differentiation here. Basically, as you can see here, more of the larger bars, and the larger bars indicate bigger differences between the prediction and the actual voting behavior, are blue shade. And the yellow outliers you can see here on the regions column, those are the Baltic states. And the Baltic states, depending on how you classify them, you could say they're more like Western or Eastern. They're kind of like the melting pot in between, right? And the right side here tends to be skewing yellow and orange, so more of the Western Germanic Romance part of Europe, basically. And prediction of both turnout and party vote shares are better for Western European countries or countries with a more dominant language in Europe, so German or French, for example. But they're worse for Eastern European countries, in particular those with Slavic native languages. So, this is where we have the biggest differences. So yes, predictive performance actually does vary across countries. And that's partly mirrored when we're looking at the effect of prompt language. So predictions of turnout are actually worse when we prompt in the native language. Only for Poland, there isn't much of a difference, but it's already really bad to begin with. So the difference between actual and predicted turnout for Poland is at about 40%, regardless of how you prompt it. And then for some of these test cases, this was also the case for predictions of party vote shares, but the difference there isn't as large. So not as big of an effect of prompt language. Now, when it comes to the amount of information that was included in the prompt, so we had, demographics only versus adding some attitudinal information about people, we see a much clearer picture. So providing only demographic information leads to much worse predictions, regardless of the prompt language. And you can see this here plainly because when we calculate the difference in difference, so this is getting a bit, meta here, between the predicted and the actual values between the demographics version and the full prompt version, the values are almost always positive here. For turnout, they're always positive, and then for vote shares, they're positive in most cases, which means that the divergence is almost always higher for the demographics only version of the prompt. And we actually also found that the variance in differences between predicted and actual party vote shares was lower when using demographic information prompts. So that suggests that the LLMs are just sort of systematically off. They're not differentiating between profiles as we would like them to. And so all the charts that I've shown you so far actually were the results for GPT-4 Turbo, just because, you know, dimensionality, reduction of complexity there to not show you too many charts. But we, of course, did also test this for Llama and Mistral. And there we can actually draw the same overall conclusion, which is that LLMs aren't really a good idea in this case. Llama's predictions were actually showing really similar patterns to GPT, but they were even more off overall, and they were even more biased against certain countries. They also had higher shares of missing predictions on the individual level, so, you know, not returning a prediction for a specific person. On average across countries, this was actually 114 times higher for turnout. So this is because, you know, for GPT, it was really low. It was like 0.02% of personas that didn't get a completion or a response. And for Llama, this was 1.8%. So almost 2% returned like no predictions. And that was actually 15 times higher for vote shares. So there we had 0.2% of missing completions in GPT and 2.5% of personas that didn't have a completion when using Llama. And this was actually especially the case in Poland and Slovakia and other countries where we use native language prompting, showcasing that Llama actually performed worse when prompted not in English. And Mistral, on the other hand, was completely unable to fulfill the task. It ignored the instructions to make as good a prediction as possible, given the available information and keeping the response concise. So either it was hesitant to give a definitive answer and said like, oh, I can't answer this based on this information, or it just really rambled on and was cut off by the token limit, resulting in a lot of missing values for predictions. And we also found that there were more missing values when only prompting with the demographic information. So to sum up, just because you can create synthetic samples with LLMs doesn't really mean you should. But can you even? In our case, we would say you can't because, you know, those predictions of the European Parliament elections failed. They overestimated turnout. They were unable to accurately predict the winner, the rank ordering, individual party vote shares. They were especially off for Eastern European countries and countries with native Slavic languages, and they were especially off given only sociodemographic information about individual voters. So, of course, there are some things that could possibly improve the predictions. So like I mentioned earlier, we wanted to ensure comparability and see how LLMs perform in different settings given the same information. And in addition, more detailed survey data allowing for more sophisticated forecasts like past voting behavior, how likely a person says they would vote, which is stuff you typically use in forecasting models, simply wasn't available from a data set that both covered all the countries we were interested in and was as recent as possible before the election. So again, you know, not trying to do this after the election, but actually making a real prediction. And that's a key trade-off in this debate, right? Like the breadth versus the depth versus the recency of the data. Because ideally, we would have recent and detailed data to build the personas, but then we might as well just skip that step and just add the question we want to ask the LLM to the survey we need to field to get that data that we need. And then relatedly, of course, it would be ideal to use a pre-election panel where we also maybe ask about intended voting behavior or likelihood to vote and use that for LLM input. And then we can compare the predictions to the post-election survey of the same people and see whether it was correct. But once again, such data isn't really available so shortly before an election unless you collect it yourself, which, you know, again, kind of defies the purpose. And that would undermine the goal of trying to recycle existing data. So while it's possible that LLMs could perform better given better data circumstances, that wouldn't really be a realistic or interesting use case. And we already established in the study that we did in Germany that LLMs can't really replicate survey-reported voting behavior or the results of predictive models built on that survey data. And our goal here was kind of to compare to a real outcome and not what people have responded to in a survey. What we could have done is that we considered different electoral systems and thresholds when processing the predictions. So for example, Ireland has a really complicated electoral system. It has a ranked choice system that's more complex than just adding up individual parties' votes, which is what we did here. So there was some, bias introduced from that. We also could have included data on countries' effective number of competing parties, which probably impacts strategic voting, also electoral volatility, whether people tend to, be more volatile in their voting behavior in a specific country in general, or even just the national electoral cycle. Because maybe, if depending on how far the last national election was away, people might tend to punish the governing party more than others that just had an election. And those are additional analysis that would be really interesting to look at from a political science point of view. I have my degrees in political science, so I'm all for looking into that as well. And in this case, we for now took a survey methodology perspective to kind of seek to identify new biases and see whether LLMs are off and whether they're off more for some contexts than for others. So that was just kind of a different perspective that we were taking. But also, I'm thinking some of these differences were so big, it's, unlikely that this was due to factors like, the effective number of parties or other country level factors alone. So, lucky for survey researchers, which I think we have a bunch of here, surveys ain't dead just yet. So as we've seen, really off-the-shelf LLMs, which are, LLMs that we just take as they are, don't really live up to this hope of being a resource efficient alternative to surveys in just any context out there, which shouldn't be surprising because LLM's success at completing any task that you give it depends on the purpose, that is the architecture of the LLM, how it was built, and of course its input that we talked about, and the training data, the prompt. So remember, LLMs weren't made for predicting public opinion. They weren't made for that, at least not the ones that we just, can access through the internet that we don't customize. They were made for predicting the most likely next word in a sentence, which is not the same thing. And there's a lot of issues with temporality in training data. It always has a cutoff, so it means it's not updated with new information in real time. But of course, real life public opinion and the composition of the population who holds that opinion constantly changes. And as we've seen, we really need detailed information about people for creating samples, but that detailed information will be outdated because survey data takes time to be publicly available. And then, of course, LLM training data will always be behind current events, which influence public opinion. Newer versions of LLMs, so since then, can actually search the web, but we need testing on how that can be used for public opinion estimation effectively. So that would be something interesting to look into next. But basically, if we still need detailed individual attitudinal information for LLMs for making predictions, then the LLM-based synthetic sample isn't really an advantage because we still need surveys to get that information. So where does that ultimately leave us for the future? Well, we need more transparency in LLMs to pinpoint where the bias actually comes from and to be able to mitigate it. So for example, we could do this by testing different model architectures and different training corpora, so varying what the LLM is trained on, which weights was it used, which internal weights did it have, and how was it aligned, where does the bias actually come from? And it's probably multiple sources, but we could try to pinpoint those better. But this, of course, would require LLM providers to be a bit more transparent about their models and researchers to actually have the computing resources to do such tests, because those would be much bigger than what we just did. But in absence of this, we would have to have some workarounds. So a colleague of mine has actually been doing a follow-up study to ours to identify how LLMs map information that we give it in a prompt to political preferences under the hood to kind of show where the bias occurs, which is really exciting stuff. And then when it comes to computational social science applications of LLMs, so not just off-the-shelf LLMs that we talked about, there's actually people that are already working on customizing LLMs for estimating public opinion or for improving them for specific coverage contexts. So there's researchers that have started to fine-tune models with survey data, for example, based on this initial German experiment that I just mentioned, or also in the US with the General Social Survey. what is fine-tuning? For those of you who don't know, basically the LLM knowledge is updated with specific information and then the desired output for a specific situation. So then when it gets prompted later with a similar situation, then it has learned to respond in a certain way, which has been shown in other cases to improve predictions. And so in this case, this would be that we give an LLM a concrete example of how specific individuals and subgroups voted to incorporate that information into the prediction. So we give it examples of these little profiles and actual vote choice, maybe from a survey, reported vote choice. There's still some error there, but as good as it gets. And then there, what has been tested so far, the method works mostly retroactively. So for item and unit non-response on, survey data that we already have, not so much for future outcomes, but we're probably getting there really fast. We could also fine-tune LLMs with social media data to give it more information about current events and public reaction to those to kind of circumvent or fix that temporality problem a bit. And then finally, there's also projects like Trust LLM in Sweden, which is optimizing LLMs for European languages and values. So that hopefully also helps diversify the applications if LLMs are better aligned to different viewpoints. But ultimately, really, I think it's unlikely that LLMs are able to outright replace surveys, especially considering that we have really high quality gold standards with surveys. But we have to think about whether they're fit for purpose, right? Even if they're not perfect. If they can give us additional insights that we cannot find anywhere else, it might be acceptable to integrate them with other data sources such as surveys and use them to augment it. But for that to happen, we need to know the biases and adjust for them. And yeah, as I've just said, there's a lot of work to be able to get to that point, really. So key takeaways for today is that as of now, LLMs can't replace survey data. They can at most augment it because they need detailed survey information even to make bad predictions. Second, applicability of LLM-generated survey data is context-dependent. Its output is biased towards certain subpopulations. In our study, it was Eastern European countries and languages that were worse off. Third, performance is likely to improve with fine-tuning. For example, public opinion data and research or information about current events, which could help with future predictions, but it also means we still need survey data for fine-tuning. And then lastly, more research is needed for identifying and mitigating the biases in LLMs. And with that, thank you for having me today. I very much look forward to your questions, whether now verbally in the chat or through email. Happy to connect.
Very exciting. Thank you so much, Leah. Great talk.
Yes.
Great topic. So very timely. Well done. Thank you so much. Also thank you so much for having questions in between. But still, we have about 25 minutes to grill Leah. We should use that time. So who wants to go first? Questions for Leah?
I think we have some in the chat that I didn't catch up on, but I'm also happy to take. Shoot away.
I can take. So we have Christina. I can double check questions in the chat, and so we just keep going.
Sounds great.
Go ahead.
Go ahead, Christine. Yeah.
I think it's your turn, Christina. Christina Kwirk.
Oh, me. Are you talking to me?
It's you.
Oh,
yes,
I think
I do.
I'm sorry. I thought you were looking at the other Christina.
It's okay. Go ahead.
I think you answered my question. I didn't fully understand how you develop these personas, but you actually took every respondent in your survey and compiled a demographic and in part of the cases attitudinal persona and attributed that to that specific person. Is that correct?
Exactly. Yeah.
Okay, then you answered it. Thank you.
Great.
Further questions for Leah in between. So we have a question by Ted Lee, or more common, or I don't know. So the fail of estimation could be caused by the selection bias of survey. So what's your opinion on
that? Yes. So of course, surveys aren't perfect either. We know that. We try to improve that. I would say that in this case, we tried to find, as good of a survey as possible, of course. So, really good sample in terms of, multi-stage stratified random sampling or probability sampling. Of course, there always is some selection bias there as well. But basically that's as good as it gets. So there's currently like no way of fixing that. I'm not, as much as I wish I was, I'm not an expert pollster. So maybe people at CNN or somewhere else like have better methods of, calibrating survey samples. So my short answer would be yes, maybe that's part of the reason, but still, we also know from other studies that if we just try to, use surveys as a prediction of election outcomes, those are actually better.
Thanks. Just by the way, maybe you're not an expert pollster, but it seems you're an expert LLM-based pollster, right? And so I'm not sure if we had that question, but again, so please feel free to raise your hand. So we have another, or just unmute yourself. So I'm not sure if you addressed that comment. Every person in the survey had a profile then.
Yeah, exactly. So we
Okay.
had, yeah.
It's a yes, no answer. It's yes, I guess then. Thank you so much. So then we have another question. Could you comment on how the performance might have improved if the temperature was set closer to 0 without fine-tuning versus with fine-tuning?
So it's kind of like a double-edged sword. So on the one hand, we would get, like the most likely response. So, if for whatever reason, then the person would be, most likely to be voting social democratic or whatnot, then we would have that reflected in the output. But on the other hand, what temperature does, basically by setting it really low or setting it to 0, it just artificially flattens this probability distribution. So in a really basic case where you only have two parties, right, like multi-party system here, but let's make this easy for the thought experiment. If you had two parties and in this probability distribution, it was, based on the profile, it was 51% probability for the prediction to be Social Democrats and 49% probability for that prediction to be conservative, then it would always pick Social Democrats, even though that would be a really close call, right? Like that person might as well, just from its whatever we know about it from, our little persona or beyond that, be almost just as likely to vote conservative, but then just because we forced the LLM to pick Social Democrats, it will give us that. So for some people, that might actually be the correct answer, but then for some, especially because we're thinking vote switching and volatility, that would actually artificially just force it to take the option that the person should vote for because political science theory, when in reality, it's almost as likely that the person would vote for a different party. So that's why we didn't do that.
We have a next question. So I'm just keep shooting, okay?
Yes.
Perfect. OpenAI measured the bias in their machine by comparing the synthetic result in the US with questions and results from US peer research. Perhaps the same could be done in Europe with the Eurobarometer data and see if that results correlates with the EU election experiment you ran. Would the biases be the same?
Okay, I can see it in the chat and have to reread it just to wrap my head around.
Go ahead, please.
In the machine by comparing the synthetic results in the US. Yes. Yes, it could be. I guess that's kind of like, would be similar to, yeah, just basing or like comparing to what people reported to in a survey. So we kind of like have a three-way comparison, right? Between the LLM predictions, between whatever was said in a survey and then the real outcome. And then we could compare, or who's better, the survey or the LLM, like directly. Definitely. That would be interesting.
We have another, I think this is just a comment. So using ANES surveys in the US over this over time series, vote intention a few months before the election has an error of about 3 points, predicting the incumbent. In other words, the survey works well as a forecasting tool. So please feel free to read it.
Right here. Other words.
I mean,
You're cut off for me, Jan. Is that me or is that you? No, are you back?
yeah. So for the second time, I got I don't know. So they.
You're back. You're back. Sorry.
threw
What were
me
you
out.
saying?
I'm back. Sorry.
Yeah. So yeah. So
but no, I don't have the questions anymore.
Right, I have them. I can just try and do it
Okay,
myself.
perfect.
About the ANES, yes, maybe this was actually more a comment to, you know, what was said earlier, as in like, oh, could the bias come from the survey? This kind of is, I think, supportive of what I was trying to say. I feel like, you know, surveys are as good as the tools we have right now. They're not perfect, but if you're going to benchmark against anything, then probably a survey is still your best bet. That would be my, I don't think it was a question, but my comment to that comment. Okay, I'll try to go from the bottom. Actually, there were two here in the Q&A that I won't ignore. The computing power, right? I said I had to get back to that.
It's up to you.
Okay, and then here, open an image of the bias, right? We already had that too. Great, and then here, can we measure the confidence interval of the sample or the margin of error? Right, great question. So this is also something that we thought about when we were doing kind of like more of the subgroup analysis just for Germany in a previous project. And we are actually hesitant to report confidence intervals on this data simply because of, you know, the data generating process. So if we're thinking confidence intervals, p-values, basically anything that's based on a statistical distribution, we're assuming that we have a simple random sample behind that, right? Like that's what we teach statistics students. Like if you have a normal distribution and all of that, then you can compute your confidence intervals and all of that. And with LLMs, that's actually not the case, right? Like it's not a, you know, random sample that we have. It's some really opaque way of getting data. And that's why we in our team feel like computing confidence intervals wouldn't really be meaningful, because the distribution that's drawn from it just doesn't adhere to assumptions that we have in statistics that would justify computing confidence intervals. Exactly. Yes, Mike. Exactly what I'm thinking. Then there was a question above. To what degree, in your opinion, does the error in predicting what to reflect the bias in the learning set? More text supporting the left, green, right. Yes. Actually, like, of course, there's reason to believe that, you know, like maybe the selected texts are also biased towards certain political attitudes. And it could be from several sources. Either the internet overall is just, you know, more left-leaning, or the sources selected for training LLMs are more left-leaning, or, and this is actually, you know, what might be, and it could again be a mix of all of those reasons, but also what we shouldn't forget is that it's not just training data that basically makes up LLMs, but also something called human feedback. So yeah, there's actually people that are optimizing LLM output, right? Like that it doesn't just, you know, for example, give back super racist responses. And because of that, if we're trying to steer that, then of course maybe tends to be, you know, less right-wing extremist if it's supposed to be less racist. And so there's a lot of talk going on about the effect of this reinforcement learning with human feedback. But then at the same time, there's some people that think that if we use base models, so models that, you know, don't have this human feedback and alignment and kind of protection to not have racist and misogynist LLMs, that those would actually not be better either, because then they would just reflect the biases of the training data even more. So it's a bit of a debate of how much harm versus good does the human feedback actually do. But yes, at some point, some sort of, like liberal bias is injected again, because LLMs weren't made for predicting public opinion. They were made to be non-racist next word predictors. Maybe there will be a truth social LLM that is, less, yeah, go ahead, Jan.
So may I follow up on that?
Yes.
So for my own work with LLM-based bots, so what we just recently figured out is that, I mean, I don't have strong evidence for that, but just from looking at the data and at the trials we're running, it seems when you assign personas to LLMs, it appears like there's a hierarchy of importance when it comes to the personas you assign. So, for instance, what we found is that when we try to prompt the LLM to give a positive answer towards or to an LGBTQ related question, for instance. So in some cases, the bot refuses to give a positive or a negative answer. However, this seems to be related to the persona. So for instance, if you set like a party preference, like the AfD, the Alternative for Germany, or even like the Christian Democratic Party, so we can see that the party preference somehow beats other characteristics we also set at the same time. Mm-hmm. My question now is, so what is your experience when it comes to estimating poll outcomes?
Yes. So I think this relates back to the, I feel like I keep teasing this other paper that we wrote about German elections. But it's just, of course, like this study built on that. So of course, we were informed by that. And there we also looked at, like kind of like how we ran regression models, and we looked at how are different prompt variables contributing to the actual response that we get. And we also saw that the LLM relies a lot on party identification and on ideology. So I think that kind of goes with that. It goes like, oh, this person tends to lean left. Oh, definitely they wouldn't vote for the CDU because, and like that makes sense to some degree, right? Like it's not wrong on average, but probably there's some nuance there that's like missing. Yeah. And then that kind of relates to also the work that Sarah is doing that I mentioned, that is kind of like trying to map which parts of the prompts are like, how does the LLM map different parts of the prompts to the political affiliations? Like if it hears female, does it automatically say social democrat or something, to kind of like look under the hood? But I think what you observed really aligns with what I observed, which is, it prioritizes certain parts of the prompt more than others.
So if you find another person, it's not a conspiracy anymore, right?
Exactly.
Are we still good to go?
Yeah, I mean, for
Perfect.
me.
So we still have some questions. So perhaps if you render, no, we had that, right? What about the internet problem of so many participants are young males who are computer techs?
Right. Not sure if you're referring to kind of like the people that are annotating, like the reinforcement learning or the human feedback, or the people that write the, like content that LLMs are based on, basically the training data. Yeah, I mean, obviously, if we're thinking about positionalities from a more, intersectional perspective, humans aren't objective. They're always subjective. I come with my experiences, my cultural experiences, my personal experiences, as do the people that write on the internet, as do the people that, annotate data or whatever. And we can't, blame them for being that. What we can do is diversify that pool, right? Like nobody can be blamed for their subjective opinion, but we got to make sure that we diversify that. So I do think that that's a problem, that both, annotators for LLM data and like just the training data itself is really homogeneous in terms of positionalities, where people come from, what are their experiences, what are their values.
We have another question. So do you think there are ways to improve the accuracy of the sample by using available statistical methods such as bootstrapping?
What do you think? I mean, I feel like, like doesn't sound like a bad idea. I haven't tested it. I haven't thought about it. I haven't done bootstrapping in a while, but it'd be worth testing.
Considering what you just said before, so I mean, I'm always not so eager to
like having post-survey adjustment. I just feel like, if garbage in, garbage out, you can try and weight it up in some way or another. It would probably improve it, but then based on what? Based on like a fake, like that's kind of like using quota samples and weights, right? Like you can also
right. And I mean, so from sorry for taking over now or jumping in here. So I hope this is okay with you. But
yeah.
So just seeing the discussion, and now I'm really eager to see what you say. So now we have like this post-processing perspective. However, from my experience, I mean, the most important point when it comes to LLMs, and it's the prompting. So I think it's much more important at the moment, at least I would say, to really think about how to prompt and so how to formulate prompts. They really need to be tailored. And they also really, I mean, they need to be on the point, otherwise we don't know what we get. And so for example, what I see, so if we just put in prompts so that are not straightforward formulated, it takes the LLM way longer than if we have clear, straightforward prompts. The next question is we need to ask, so I mean, do you also address that in your study? So how differently formulated prompts result in different outcomes we get. Okay. And so I think it's also important not just to think about the possibilities we have at hand after data generation. We should start before data generation or synthesizing the data. So this is just my perspective.
No, I mean, you're absolutely right. Or like, I mean, at least I agree. Again, conspiracy because we're two people. It's great. Yeah, and there's this kind, it also makes me think of, like just convenience samples and stuff, right? Like in German, like it's the worst idea to try to translate idioms, but there's this idiom in German that says like, oh, even a blind chicken sometimes finds a grain, which means, sometimes you may get it right with your convenience sample, or like sometimes if you use this prompt, wow, you get a prediction that's accurate, but then if you modify one word, you don't. So what does that tell us about the inherent state of LLMs? Like they don't know anything first and foremost, but also there's no, like what does that say about validity and reliability like I guess it's akin to asking questions in surveys. If you modify a word, you get a different response. So in a way it's fair, but also it really makes you think about what lies underneath this output that we get and the data generating process, and that's just so suspicious, like so sus.
Yeah, totally. And I think another problem is also, I mean, so for instance, Google Gemini, so they just changed the model. They just recently released the model 1.5. And I mean, we just did a data collection with one of your colleagues from Munich and from Mannheim, with Ruben and Carolina. And so we figured it out. And so I wouldn't say that, I mean, the outcomes we got from the LLM at the end, they were quite different when looking at the 1.5 model than when looking on the 1.0 model from Gemini, So also another point is what model I'm looking at.
Yes. So, I think the next thing on the horizon is basically developing a total survey error framework for LLMs, because there's so many points where error might be induced.
Yeah, good point.
Yeah.
Shall we go with the questions?
Sure. I'm also scrolling up.
Do you think we had that one? Oh, bootstrapping is overrated. Just saying.
There was...
do you see more? No, go ahead, please.
think I saw one that I missed, which is what would have been the prediction using survey data only? Obviously, new parties would be 0, but it would be interesting to see whether LLM improved or worsened the bias. Great question. We didn't look at that. So that would be interesting to kind of like build a predictive model with the prompt data, or like with the prompt variables on just, the survey data, like a regression model or whatever, to model vote choice. Definitely, that kind of relates to this whole like, oh, but what if we compare to Eurobarometer or like, pre and post election data? So all of these, yeah, comparisons, worth looking into. I don't know, but it should be looked into, and I'll write it down. It's a good question.
And I may have another question. So, looking into the future and giving a recommendation to pollsters. So, what should we do for future? In the near future. So, is it worthwhile? I mean, considering your findings, is it worthwhile just say, okay, it's not much work, so it's not much cost, so we should just like try to produce synthesized data, see what we get, and compare them to what we get from polls? Or, I mean, just
yeah.
What's the avenue
I feel like just in general, there's like two camps, right? Like there's this one side of survey research or like the polling industry that says, this is such a bad idea. Why would this work? Of course it doesn't work. Why are you even trying? And then there's the other side that's saying, but only if you did this, then it could work, and then it could work, and then it could work, right? And I feel like both are valid. So my take would be, people are doing this anyways, right? Like, I mean, there's startups, no matter how much we say like, this isn't working, this is biased, this is unreliable, it's not valid in terms of, scientific validity, like we don't know the data generating process, it's going to be done anyways. So in fact, facing that, I would say, let's try and make these models better, right? Like, let's try and customize them for public opinion research. Let's try and see if we can. If we can't, then resources are wasted. But if we succeed, then that's great, and then we can hopefully use those models instead of some trash that some bogus, I don't know, company with tech bros and lots of funding is trying to put out. Yeah, so I'm hesitant to say, like it's worthwhile in terms of what's definitely going to be successful, but I don't think there's an alternative to trying, because we actually have the knowledge. We might not have the resources, so that's what we have to apply for, but we have the knowledge to actually make this something that is somewhat acceptable, or at least more valid than what's going on right now, really. So yeah, fine-tuning, diversifying training data, annotating, collaboration with computer scientists who actually can, get a bit more technical. Yay for computational social science, really.
No, I agree. And I mean, so we also have to say, I mean, this is just like one tiny field of so many fields we can actually apply LLMs in our daily work, right? So it's, I mean, and I also see like, I mean, there's great feedback for you. So it seems you did an awesome job. Thank you so much.
I appreciate it.
I think we're at the end. So they're coming compliments in, but no further questions.
Great. Will you send the presentation?
I agree to all of them.
Why does WAPOR, how does WAPOR go about that? I don't actually know. Like, I'm happy to share the presentation somewhere, but I don't know if, how the policy is there. I know the meeting's being recorded. Maybe that's being shared somewhere. Yeah.
I mean, to my best of knowledge, and Xenia, feel free to jump in. The meeting is released online, right?
Okay, great. Okay, so it's going to be on the website. Then yes, I'm happy to put my presentation there, and then free for you to.
Perfect. Thank you so much, Leah. I wish you all the best, and see you soon.
Yes, thank you all for joining. Thank you for having me. This was a great
project. Yeah, thanks for being here today, and thanks for joining.
Yeah, thank you.
Thank you.
Bye-bye.
Goodbye. See you next time.